Welcome to The Explainer. Today, we're diving straight into a cosmic mystery, one that's making astronomers question the very foundations of how we think the universe works. We're talking about a series of gigantic discoveries that are challenging a century of scientific thought. And as you're about to see, this story is really just getting started. And this quote from the researcher behind the latest mind-bending discovery just gets right to the heart of it. What we're finding out there in the depths of space, well, according to our best theories, it just shouldn't exist. So the latest clue in this giant cosmic case comes from a team that was studying the light from these incredibly distant, bright things called quasars. You can think of them as lighthouses shining across the universe. And by tracing that light, they uncovered a structure that, frankly, sent shockwaves through the scientific world. They call it the Big Ring. It's this enormous, almost perfect circle of galaxies and galaxy clusters, and it stretches 1.3 billion light-years across. I mean, let that sink in. This isn't just a random pattern of stars. It really seems to be a single connected structure. It's almost impossible to wrap your head around just how big that is. The sheer scale of the Big Ring is staggering. And its very existence seems to fly in the face of one of the most basic assumptions we have about the universe. So what is this fundamental rule that the Big Ring seems to be breaking? It's something called the Cosmological Principle. And look, this isn't just some dusty old idea. It's the bedrock that our entire standard model of the universe is built on. Questioning it means questioning everything we think we know about our place in the cosmos. The Cosmological Principle sounds complicated, but it's actually a pretty simple idea. It basically says that on the biggest scales, the universe is the same everywhere. There are no special spots, no VIP sections. It's all pretty much uniform. Okay, so it breaks down into two key parts. Homogeneous means that matter is spread out evenly. So if you could take a giant scoop of the universe from over here, it would have roughly the same amount of stuff as a scoop from way over there. And isotropic, that just means it looks the same in every direction you look. The view is consistent. Now, this principle leads to a really critical prediction. Based on the fact that the universe is 13.8 billion years old, there just hasn't been enough time for gravity to pull stuff together into structures larger than about 1.2 billion light-years across. Think of it like a cosmic speed limit for how fast you can build things. And the Big Ring? Well, at 1.3 billion light-years, it's blowing right past that speed limit. But here's the kicker. This isn't just a one-time thing. The Big Ring is just the latest suspect in a whole lineup of cosmic megastructures that are making scientists take a hard second look at the evidence. For years now, astronomers have been finding these cosmic rule breakers. You've got the giant arc, the huge large quasar group, and the absolutely colossal Hercules Corona Borealis Great Wall. And every single one of them just laughs at that theoretical size limit. And this chart really shows you the scale of the problem. We're not talking about things that are just a little bit too big. The Hercules Corona Borealis Great Wall is nearly 10 times larger than our models say is even possible. This isn't just pushing the envelope, it's tearing it to shreds. So as you can imagine, this has kicked off a massive debate in the science world. On one side, you have people saying, is it time to rewrite the rulebook? And on the other, you have scientists urging caution, reminding everyone that our standard model has worked incredibly well for a very long time. Alexia Lopez, who found the Big Ring, is basically saying, hey, we can't just keep ignoring this stuff. Her point is, the more of these massive structures we find, the harder it is to just write them off as a fluke or some kind of measurement error. But on the other side of the coin, you have some very smart people pumping the brakes. As one skeptic points out, the standard model is supported by a mountain of evidence. You don't just throw out a theory that explains so much, not without some absolutely extraordinary proof. So the critics are asking some really tough but really fair questions. Are we sure these are actual physically connected structures? Or could they just be a trick of perspective? You know, like seeing shapes in the clouds. Has the analysis been strong enough to prove this isn't just random chance? These are the questions that has to be answered. So how do you settle a debate this big? Well, you need more data, a lot more data. You need a bigger, better map of the cosmos. You need the ultimate cosmic detective. And that is exactly where the European Space Agency's Euclid mission comes in. Euclid is basically a detective that's been sent into space to investigate the biggest mysteries out there, dark matter and dark energy. And to do that, its job is to create the largest, most accurate 3D map of the universe that humanity has ever seen. And it's going to solve this case using two really powerful techniques. First, it's going to map the invisible stuff, dark matter, by measuring how its gravity ever so slightly bends the light from over 1 billion galaxies. And second, it's going to map the visible stuff by pinpointing the exact 3D location of tens of millions of galaxies. This survey is going to be absolutely massive. Euclid is going to map more than a third of the entire sky, and it's going to look back 10 billion years into the past. Think about it. We're essentially going to get a movie of the last 10 billion years of cosmic history, showing us exactly how these structures grew, or if they're even real in the first place. Which brings us right to this moment. We're at a thrilling cliffhanger in the story of our universe. We've got this profound mystery, a really passionate debate, and a detective out in deep space right now, gathering the evidence that's going to crack the case. So the universe is on trial, basically. In one corner, you have the smooth universe, the one our theories predict, where everything is nice and evenly spread out. And in the other corner, you have the lumpy universe, the one that observations seem to be pointing to, filled with structures so huge they defy all explanation. Euclid's data is going to be the final judge and jury. Over the next few years, its map will tell us for sure if these megastructures are real, game-changing discoveries, or just cosmic mirages. Either way, the story of our universe is about to get a huge update. The only question left is, are we talking about a few small edits, or are we about to rip out the first chapter and start the whole thing over again?